Okay, hi, my name is Jackson, and I'm going to be teaching you how to do a Monte Carlo simulation using Excel. So basically, what we're going to be using this for is for a retirement fund. Say you have an initial wealth of, here I have $5 million. Seems like a lot, but we'll go with it. Um, and say we want to start that fund right now and make withdrawals. We'll say we expect to make withdrawals yearly of, here I'm saying 250,000. You can put whatever you want there. Um, I'm just getting that from 5% of my initial wealth. And say your average return is 12% with a standard deviation of 7%. Um, your inflation rate 3% and a standard deviation of inflation 1.2%. And here's that withdrawal percentage. And then here is the replication. So basically, what we're going to be doing is we're going to be replicating the simulation over and over again to kind of see what the average return is going to be for your retirement fund given these variables. Okay, so let's start. Here we can do year one, year two, year three, and continue that pattern all the way down. Say you retire in 30, oh, we'll go 40 years. So drag this out to year 40. Okay, so now our beginning balance is just going to be our initial wealth. Our wealth right when we start the fund. Our return, now here's the part where this randomness comes into play. Our return, what we expect to make each year off of our balance, we're going to calculate that using this function. We're going to go norm INV. So now we have our probability, our mean, and our standard deviation here. Our probability, since we want this to be completely random, we're going to throw the random function in here. And as you can see, if you throw double parentheses here, that's going to take a random probability anywhere from 0 to 1. 0 being 0%, 1 being 100. Okay, so that's our probability. Our mean is going to be our average return right here. So that's going to be the 12%. And since we want this same number for all of our replications, we're just going to lock that cell in using the $sign. And then our standard deviation is going to be standard deviation of our return, which is going to be the 7% here, and we're going to lock that in as well. Okay. Now here, as you can see, you get a completely random return based off of these two variables right here, what you already know from the market. So, as you can see, every single time that you enter this in, you're going to get a different return. As you can see, it's going to be completely random each time. Okay, and then to get your earnings are just going to be your return of your beginning balance. So, so say this is what you're earning so far after year one. Okay? Your inflation rate, you're also going to use that function. Now we have some statistics here on inflation, which are going to be useful. So we're going to go norm INV, and then just like before, probability, you want a random probability from 0 to 1, and then our mean. So what's our mean of our inflation rate? That's just going to be your inflation rate right here. So 3%. Lock that in. And then standard deviation of your inflation right here, 1.2%. Excuse me. 0.2%. And then lock that cell in. So here we get a random inflation each year. It's going to be random every time, and it's even going to change your return anytime you click enter. Okay, so now your withdrawal rate, this is going to be easy for year one because you have an initial withdrawal. Your withdrawal rate, you want it to be 5%, and your initial wealth is 5 million. So your withdrawal for year one is going to be 250,000. That is given. Okay. Now your end value. So after you have all of these, your end value is just going to be your beginning balance, what you started with, plus how much you earned from the fund, minus obviously what you're taking out that year or what you expect to take out that year. Your end value obviously is going to be your beginning balance for what you start with in year two. As you're approaching year end, jump back into the new year with this amount of money. Okay. To run a thread here, we're just gonna throw that in here. Now your withdrawal. For your withdrawal for year two, you're gonna take your past withdrawal times 1 plus, and then right here you're gonna take your inflation rate, because we are expecting to withdraw 250K each month or each year. But now we have to add in this. And then same as before, we're going to do beginning balance plus your earnings minus your withdrawal rate. Okay, so now you can see here, after just one replication of a 40-year interval, so say this is someone doing this after 40 years, well, that's pretty good. You're going to get an ending balance of $155 million, which is well above your starting end value. So now, replication 1, throw that in right here. That's our first replication. Okay, so now we're gonna do that for, we'll just go on. Okay. So now we can start with our first replication here. Okay, so now what we're gonna do, we want to replicate this exact scenario, this 40-year scenario. We're saying 500 times we want to replicate that, just so we get enough replications so that our distribution will become narrower around a single value, around a mean value. Okay, this way, if we have a certain mean value, we can clearly identify what our average return is going to be and decide, okay, well, is this a good investment or is this not? Maybe we should be withdrawing at a lesser rate so we have an ideal amount of money that we want by retirement. Okay, so we're going to highlight all of this. We're actually going to go to data and then what if analysis right here. And then we're going to go to data table. And then, so there's no rows because we want them all in this column right here. But if we're just picking an input cell, Excel needs any cell to do a calculation. So we're just going to pick random cell right here. And here we go. So here is our replication. So let's start with the average. We can calculate the average of all of these by using this function. Average, and then just take all of these replications. So here our average future value return is going to be almost $212 million. So right now it's looking like this is a pretty good investment. The median, so the median, same kind of deal. We're going to calculate it using the median function right here. Here's our median. So basically the midpoint of all of our data values. And then we're going to go percentiles here. Your minimum return is actually going to be 2 million. So you can lose money in this case. So, like I said before, these are extremely useful, especially these descriptive statistics. If you want to throw your money into an IRA or a retirement, any kind of retirement fund, but you're not really sure if it's worth your time, play around with this, play around with your withdrawal rate, throw in a bunch of replications. You know, the more replications you use, the more precise estimate you're gonna get. So looking like we're making a good amount of money here, but you can do this for any value. Yeah, play around with it, and that is the retirement withdrawals. Thanks.